Hello, good afternoon. My name is Diego Alonso Vasquez Santiago. In this video, I will show you the first activity of Microcontrollers Module, that is the automatic monitoring system. Well, let's begin. This is the first part of the video, that is the code, and we'll be showing to the simulation in Proteus. So here are the first ones, the configuration bits for our PIC that we're using. In this case, we're using PIC 16F8778. Well, here we include the libraries that we need. We define the frequency of the clock that we are using. Here we define these three are pins, specific pins for the LCD, and these are the specific pins for the dip switch that we'll be using to activate the manual, the automatic, and the temperature and light functions. Here are, well, he defined like a constant that will be our analog to digital reading. That is the value that we'll be converting with the microcontroller. So then here we have the constants that we use on the LCD. And well, here we initialize our ports. These voids are only functions. The main code is down. So we're going to analyze this. For example, here, the port C, only the ones that are marked with 1 are the ones that are going to be inputs. So as we have here, RC4, 5, and the other ones will be inputs. So we define as that. All the port B is an output. All the port A is going to be analog is going to be input. And D, we define the same as the other one. So it goes from pin 0, 1, 2, 3, 4, from 0 to 7, from right to left. So we define that. And now for the analog to digital converter, we must check the datasheet of the PIC in order to check what kind of clock we're using. In this case, I have this configuration because of the 20 megahertz clock. And then, well, we define all the PCFG to indicate where it's going to be our reference voltage. In this case, we'll be using analog 3 pin. And the other functions here and this one are really just to turn this one is just to turn the ADC module on, and this one is to justify to the left the AD conversion. So in this case, these are only functions for the LCD in order to work correctly. And well, these two. And in these ones, we're going to set the port analog 1 and analog 2, one for temperature, that's going to be analog 2, and one for the light, that is going to be analog 1. Here's like where it's going to be the solar panel, and this is the temperature sensor, LM35. And we convert the general formula for analog to digital conversion. And then we have another functions for the LCD, for example, the shift characters. And we got to the main. In this one, we're first gonna display my name and my career in the LCD. Then we are gonna show like a welcome message that says monitoring system V1, version 1, and then in this while is gonna be like an infinite one, in which we are going to be working on this while this one is happening. It means always. So here we have it. If we have all the switches down to 0, it's gonna be looping a message that it says, for example, like selection for auto mode, use 1, and for manual mode, use 2. Then if manual mode is activated and auto is in 0, and we indicate that the light, so we're going to show that we are in the manual mode, and we are going to show the light that is given by the panel. We call the function set analog 1 because remember that we set it here as light. So the same occurs when we have manual mode, but when we have temperature, Now we switch and set analog 2, and we display the data of the sensor here. Now, if we have the automatic mode, we're going to show in the LCD that we are in the automatic mode, and we are going to be looping between temperature and light every 2 seconds. So we change automatically. That is why we activate the automatic mode. And then these other two are just like error messages in which we, for example, if we activate manual mode and automatic at the same time, it would show error only one mode. And here, if we are in the manual mode and we activate temperature and light at the same time, it would say error only one variable. So this is all the code that I made, and let's see how it works in Proteus. Here's the simulation in Proteus. We have the LCD, the dip switch. These are just like indicators, like LEDs, in order to identify in which mode are we working on. Here are op amps for amplifying the voltage to 5 volts. And here we have a potentiometer that simulates the solar panel. So we're going to run the simulation. And we can see that first, it's my name and my career, monitoring system version 1, and then, well, start working. We have all in 0, so this message is displayed. When we turn on the automatic mode, it showed automatic mode, light, and temperature. And we can see that it's correct. We have here, well, 19, but it shows 18.2, so it's okay. And this, if I vary the voltage, it will show more light. For example, there, it will show the 100%. So it's doing it. So the automatic mode is right. Now we turn off the automatic mode and we turn on the manual mode. And here we have to select, obviously, a variable. So for example, if we want light, we turn off light, and we're having the value. If we change, obviously it will change in the LCD. And well, we turn out the light and turn on the temperature mode. So we are getting the value of the sensor. If we turn on both, it will show the error, only one variable. And otherwise, it will work. And obviously, also, if we turn on like the 2 modes, it will say error, only one mode. So with this, we can see that the simulation is working correctly with the code that we just made.